Article 502.12 in the National Electrical Code, NEC, specifically addresses real-type collectors. These are devices that maintain electrical continuity between a fixed and a moving conductor. Track-type cabling systems are not explicitly mentioned in Article 502.12. However, the NEC provides guidance for other types of collectors in Section 502.10. Section 502.10 states that other types of collectors must meet these requirements. Firstly, provide adequate electrical contact. Secondly, be mechanically secure. Thirdly, be protected from the weather. And fourthly, not pose a fire or explosion hazard. The NEC requires that all electrical equipment installed in Class Roman II Division 1 Group F locations be suitable for the hazardous location. This suitability means the equipment must be designed and constructed to prevent the ignition of flammable gases or vapors. To determine compliance of a track-type cabling system with code, the following steps should be taken. Firstly, review the manufacturer's specifications for the track-type cabling system. Secondly, verify that the system is designed for use in Class Roman II Division 1 Group F locations and that it meets the requirements of Section 502.10. And thirdly, obtain approval from a qualified electrical inspector. An inspector can assess the system and determine if it meets the necessary code requirements. Additional considerations beyond code compliance include cost, where track-type systems can be more expensive than real-type systems, maintenance, where track-type systems may require more frequent cleaning and maintenance than real-type systems, and environmental factors, where track-type systems may be more susceptible to environmental factors such as dust and dirt than real-type systems. Article 502.12 addresses real-type collectors, focusing on maintaining electrical continuity between fixed and moving conductors. While track-type cabling systems aren't directly mentioned in Article 502.12, Section 502.10 provides guidance for other collector types. Section 502.10 outlines key requirements. These include, firstly, ensuring adequate electrical contact. Secondly, providing mechanical security. Thirdly, offering protection from the weather. And fourthly, preventing fire or explosion hazards. For Class Roman II Division 1 Group F locations, the NEC mandates that all electrical equipment be suitable for the hazardous environment. This suitability involves designing and constructing the equipment to prevent flammable gas or vapor ignition. To confirm compliance of a track-type cabling system, specific steps should be taken. Firstly, a review of the manufacturer's specifications for the track-type cabling system must occur. Secondly, a verification of the system's design for use in Class Roman II Division 1 Group F locations is required, ensuring it meets Section 502.10 standards. Thirdly, obtaining approval from a qualified electrical inspector is necessary for assessing the system's adherence to code requirements. Beyond compliance, factors such as cost, maintenance, and environmental susceptibility should be considered. Track-type systems may present higher initial costs compared to real-type systems. Maintenance demands may include more frequent cleaning. Environmental considerations should account for potential susceptibility to dust and dirt. Class Roman II Division 1 locations involve the presence of combustible dust in the air in sufficient quantities to produce explosive or ignitable mixtures, or where mechanical failure or abnormal operation of equipment could cause such explosive or ignitable mixtures to be produced, and might also provide a source of ignition through simultaneous failure of protective equipment, or where combustible dust of an electrically conductive nature may be present. Group F atmospheres contain carbon black, charcoal, coal or coke dust. Considering these factors is crucial when evaluating the suitability of track-type cabling systems in such hazardous environments. In essence, the transition from real-type collectors to track-type cabling systems in Class Roman II Division 1 Group F locations demands careful evaluation. Firstly, one must consider the NEC guidelines, especially Section 502.10. Secondly, one must verify system suitability for hazardous environments. Thirdly, one must account for practical aspects like cost and maintenance. By addressing these considerations comprehensively, you can ensure a safe and compliant installation. A qualified electrical inspector plays a pivotal role in assessing whether a track-type cabling system meets the NEC requirements for Class Roman II Division 1 Group F locations. Their expertise ensures that the system is safe and suitable for the intended environment. This assessment includes verifying that the system provides adequate electrical contact, is mechanically secure, protected from the weather, and does not pose a fire or explosion hazard. The inspector will also review the manufacturer's specifications and documentation to ensure that the system is designed for use in the specific hazardous location. The approval from the inspector is a critical step in ensuring compliance with the NEC and ensuring the safety of the installation. When considering the installation of electrical equipment in hazardous locations, it is essential to refer to the National Electrical Code, NEC, which provides specific requirements for different types of hazardous locations. The NEC defines hazardous locations based on the type of hazardous material present, the likelihood of the hazardous material being present, and the properties of the hazardous material. Class Roman II locations are those where combustible dust is present. Division 1 locations are those where the hazardous material is present under normal operating conditions. Group F locations are those where the hazardous material is carbon black, charcoal, coal, or coke dust. The NEC provides specific requirements for electrical equipment installed in each type of hazardous location. These requirements are designed to minimize the risk of ignition of the hazardous material. Electrical equipment installed in Class Roman II, Division 1, Group F locations must be designed and constructed to prevent the ignition of the combustible dust. This includes using explosion-proof enclosures, intrinsically safe circuits, and other protective measures. It is important to carefully review the NEC requirements for the specific hazardous location before installing any electrical equipment. Failure to comply with the NEC requirements can result in serious injury or death. In addition to the NEC requirements, it is also important to consider the manufacturer's recommendations for the installation and maintenance of the electrical equipment. The manufacturer's recommendations may provide additional information on how to safely install and maintain the equipment in the specific hazardous location. It is important to follow both the NEC requirements and the manufacturer's recommendations to ensure the safety of the installation. Before replacing a rail-tight system with a track-tight system in a Class Roman II Division 1 Group F location, several factors should be carefully considered. Firstly, a track-type system must be specifically designed and certified for use in Class Roman II Division 1 Group F locations. This certification ensures that the system meets the stringent requirements for preventing ignition of combustible dust. Secondly, the track-type system should be installed by qualified personnel who are familiar with the NEC requirements for hazardous locations. Proper installation is critical to ensure that the system operates safely and effectively. Thirdly, the track-type system should be regularly inspected and maintained to ensure that it continues to meet the NEC requirements. Regular inspections can help identify potential problems before they become serious. Fourthly, the track-type system should be compatible with the existing electrical system. Compatibility is essential to ensure that the system operates safely and reliably. Fifthly, the cost of the track-type system should be considered. Track-type systems can be more expensive than rail-type systems, so it is important to weigh the costs and benefits before making a decision. By carefully considering these factors, you can ensure that the track-type system is a safe and effective replacement for the rail-type system. When selecting a track-type cabling system for a Class Roman II Division 1 Group F location, it is important to consider the following factors. Firstly, the system's enclosure rating must be appropriate for the environment. The enclosure rating indicates the level of protection that the enclosure provides against dust, water, and other environmental factors. A higher enclosure rating provides greater protection. Secondly, the system's temperature rating must be appropriate for the environment. The temperature rating indicates the maximum temperature that the system can withstand without being damaged. A high temperature rating is required for environments with higher temperatures. Thirdly, the system's materials must be compatible with the environment. The materials used in the system must be resistant to corrosion and other forms of degradation. Fourthly, the system's design must minimize the risk of ignition. The design of the system should minimize the accumulation of dust and prevent the formation of hotspots. Fifthly, the system must be properly grounded. Proper grounding is essential to prevent electrical shock hazards. Sixthly, the system must be installed in accordance with the NEC and all other applicable codes and standards. Compliance with codes and standards is essential to ensure the safety of the installation. Seventhly, the system must be inspected and maintained on a regular basis. Regular inspections and maintenance are essential to ensure that the system continues to operate safely and effectively. The NEC provides detailed requirements for electrical installations in Class Roman II, Division 1, Group F locations. These requirements are designed to minimize the risk of ignition of combustible dust. Some of the key requirements include: firstly, all electrical equipment must be approved for use in Class Roman II, Division 1, Group F locations. This means that the equipment has been tested and certified by a recognized testing laboratory to meet the requirements of the NEC. Secondly, all electrical equipment must be installed in dust-tight enclosures. Dust-tight enclosures are designed to prevent the ingress of dust. Thirdly, all wiring must be installed in rigid metal conduit or intermediate metal conduit. Rigid metal conduit and intermediate metal conduit provide a high level of protection against physical damage. Fourthly, all electrical equipment must be properly grounded. Proper grounding is essential to prevent electrical shock hazards. Fifthly, all electrical equipment must be inspected and maintained on a regular basis. Regular inspections and maintenance are essential to ensure that the equipment continues to operate safely and effectively. In addition to the NEC requirements, it is also important to consider the manufacturer's recommendations for the installation and maintenance of the electrical equipment. The manufacturer's recommendations may provide additional information on how to safely install and maintain the equipment in the specific hazardous location. Before installing a track-type cabling system in a Class Roman II, Division 1, Group F location, it is important to carefully review the NEC requirements and the manufacturer's recommendations. It is also important to consult with a qualified electrical inspector to ensure that the installation is in compliance with all applicable codes and standards. Track-type cabling systems offer several advantages over reel-type systems in Class Roman II, Division 1, Group F locations. Firstly, track-type cabling systems are typically more reliable than reel-type systems. This is because track-type cabling systems do not have any moving parts, which reduces the risk of failure. Secondly, track-type cabling systems are typically easier to maintain than reel-type systems. This is because track-type cabling systems do not require lubrication or other maintenance. Thirdly, track-type cabling systems are typically more resistant to environmental factors than reel-type systems. This is because track-type cabling systems are typically enclosed in a dust-tight enclosure, which protects them from dust, moisture, and other environmental factors. Fourthly, track-type cabling systems are typically safer than reel-type systems. This is because track-type cabling systems do not have any exposed moving parts, which reduces the risk of injury. However, track-type cabling systems also have some disadvantages compared to reel-type systems. Firstly, track-type cabling systems are typically more expensive than reel-type systems. Secondly, track-type cabling systems are typically more difficult to install than reel-type systems. Thirdly, track-type cabling systems are typically less flexible than reel-type systems. Ultimately, the decision of whether to use a track-type cabling system or a reel-type system in a Class Roman II, Division 1, Group F location depends on the specific application. If reliability, ease of maintenance, resistance to environmental factors, and safety are the primary concerns, then a track-type cabling system is likely the better choice. However, if cost, ease of installation, and flexibility are the primary concerns, then a reel-type system may be the better choice. The selection process should involve a thorough evaluation of the specific requirements of the application and a comparison of the advantages and disadvantages of each type of cabling system. Consulting with a qualified electrical engineer or inspector is highly recommended to ensure that the selected cabling system is appropriate for the intended use and meets all applicable codes and standards. Factors such as the length of travel, the weight of the cable, the operating speed, and the environmental conditions should all be considered when making the selection. Additionally, the availability of qualified personnel to install and maintain the cabling system should be taken into account. By carefully considering all of these factors, you can make an informed decision about whether to use a track-type cabling system or a reel-type system in a Class Roman II, Division 1, Group F location. When designing an electrical system for a Class Roman II Division 1 Group F location, several critical factors must be taken into account to ensure safety and compliance with the National Electrical Code (NEC). These factors include, firstly, equipment selection, where all electrical equipment, including track-type cabling systems, must be specifically approved for use in Class Roman II Division 1 Group F locations. This approval signifies that the equipment has undergone rigorous testing and certification to ensure it will not cause ignition of combustible dust. Secondly, enclosure requirements, where all electrical equipment must be housed in dust-tight enclosures. These enclosures prevent the ingress of dust, which could lead to overheating or ignition. The enclosures must be properly sealed and maintained to ensure their effectiveness. Thirdly, wiring methods, where wiring must be installed in rigid metal conduit or intermediate metal conduit to provide a high degree of physical protection. These conduits protect the wiring from damage that could expose conductors and create a spark hazard. Fourthly, grounding and bonding, where proper grounding and bonding are essential to minimize the risk of electrical shock and prevent the buildup of static electricity, which could ignite combustible dust. All equipment and metal enclosures must be properly grounded and bonded together. Fifthly, overcurrent protection, where overcurrent protection devices, such as circuit breakers and fuses, must be carefully selected and coordinated to protect the electrical system from overloads and short circuits. These devices must be sized appropriately to prevent nuisance tripping while still providing adequate protection. Sixthly, maintenance and inspection, where regular maintenance and inspection are crucial to ensure the continued safe operation of the electrical system. This includes inspecting enclosures for damage, checking wiring connections, and testing grounding systems. Seventhly, ventilation, where proper ventilation can help to prevent the accumulation of combustible dust. Ventilation systems should be designed to minimize the risk of dust being drawn into electrical equipment. Eighthly, signage, where appropriate signage should be used to warn personnel of the potential hazards in the area. This signage should clearly identify the Class Roman II Division 1 Group F location and any specific precautions that should be taken. By carefully considering these factors and adhering to the NEC requirements, you can design an electrical system that is safe and reliable for use in a Class Roman II Division 1 Group F location. It is important to consult with a qualified electrical engineer or inspector to ensure that the design meets all applicable codes and standards. The NEC is a complex document, and it is essential to have a thorough understanding of its requirements before designing or installing any electrical equipment in a hazardous location. The proper selection, installation, and maintenance of electrical equipment are critical to preventing fires and explosions in these environments.